We now show that this given equation, that is negative x cube negative 8x squared plus 25 equals 0, has at least one solution in the interval negative 2 comma 4. We are going to do this using the intermediate value theorem. So here I have outlined the intermediate value theorem. Let's have a quick review of this intermediate value theorem. So if f is a continuous function over the interval a comma b, and k is some number between f of a and f of b, we will understand this diagrammatically. This is f of x. This is the graph of the f of x defined between the intervals a and b. And we can see that k lies between f of a and f of b. So then there exists a number c, that is c lies between a and b, such that f of c equals k. So we can easily determine this from the graph, because when k lies between f of a and f of b, obviously c should lie between a and b. So let's use this intermediate value theorem to prove that it has at least one solution. So here we have f of x equals negative x cube negative 8x squared plus 25. And I'm going to find the function value at these two endpoints, that is negative 2 and 4. So at x equal to negative 2, we'll find f of negative 2 by replacing all x in f of x by negative 2. So therefore this becomes negative of negative 2 cube minus 8 times of negative 2 square plus 25. Let's simplify this. Negative 2 cube is negative 8. We already have a negative. So therefore this is positive 8. And this is a negative 2 square is a positive 4. So positive 4 times of negative 8 is negative 32 plus 25. And this equals 1. Now let's find f of 4, that is the other endpoint. This is f, we have to find at x equal to 4. This is f of 4, and this equals, we have to replace all x by 4. Therefore this becomes negative of 4 cube minus 8 times of 4 square plus 25. So negative 4 cube is negative 64 minus 4 square is 16. 16 times 8 is negative 128 plus 25, and this equals negative 167. So we now determine the function values at two endpoints, that is f of negative 2 equals positive 1, and then f of 4 equals negative 167. And so definitely 0 lies between these two values, because if we plot this values, let's say that this is f of negative 2 and this is f of 4. F of negative 2 is 1. Let me plot it here. And f of 4 is negative 167. Let's say that this is negative 167. So here it is this point. So the graph is defined like this. And clearly it should cross the x-axis, that is at some point of x between negative 2 and negative 2 and 4, uh, this should become 0, because this graph would not be able to move from negative 167 to positive 1 without crossing 0. So at this point, that is, this is the point C, this is f of c should equals 0. So all that we have to show that this satisfies, or this has at least one solution, is that we have to determine the function value at the endpoints, and one of them has to be positive. Clearly this one is positive, and one of them has to be negative, and clearly this is negative. So that we can definitely see that 0 lies between a positive quantity and a negative quantity. So we have just proved that this equation has at least one solution, so uh, between the given interval. which we can write down this as f of c equals 0, where c is the uh, x value which lies between -2 and 4. Here I have plotted the graph of the function f of x on the Desmos graphing tool, and you could plot this on any graphing tool, and you'll be getting the similar graph. So this graph is defined from -2 to this is +4, and we can see that at -2 it is 1, and at +4 it is -167. So the graph definitely crosses this x-axis, and we can see from this graph it crosses at c. Basically we have to determine the c, which is the solution of the graph, so which is 1.613 at x equal to c, that is at x equal to 1.613, the function value becomes 0, that is f of x equals 0, which in fact is the solution to the graph. So we can see that the solution to the graph is x equal to 1.613.